All right, my name is Brandon Clayton, the Algebra Guy. Today, as you see on your screen, we'll be talking about how to subtract mixed numbers. How to subtract mixed numbers is similar to adding, but it has a couple of things you want to pay attention to. By the end of this lesson, you should be able to answer this question. So how do you do that one? So you probably intuitively thinking it's just like adding, but again, I want to make sure we go over a few problems that will help. So two questions I want to answer. How can we model subtraction of mixed number? How do we model it? So I want to show some circles about what it looks like, what's actually going on behind the numbers. And then let's show two ways that we can subtract those mixed numbers. So let's get into it. So what if you were given a whole pizza and then asked to share a third of it with your sibling? How much would you have left? Or better yet, to our question, how would you model that? So I want to pull this up, get my drawing tool out here so I can draw it with us. So how would you model it? So we have one pizza. I'm going to shade this in and say this is our whole pizza. And we have one pizza and we're taking away 1/3. So what does it look like to take it away? So let's say our next step is we have a pizza, one whole pizza, and we know that this pizza needs to be divided into threes. Bam, bam. So these are still shaded in. I'm going to use a different color so you can see it. So what is take away 1/3? So if I'm taking away 1/3, I'm actually going to have to just erase one of these pieces. And when I do that, as you can see, I have left 2/3. So this 1 minus 1/3 is giving me 2/3 that's remaining. So it's pretty straightforward. Hopefully you can see that visually, but let's try another one. Let's talk about what instead of a one whole piece, what if you had two whole pieces? How would we model that? So we could do a pizza here. Actually, let me see if I can use my drawing tool. Don't shut down on me. All right, so let's say we have a whole pizza. And actually, I'm going to use, let's try this. We got two whole pizzas. And we're going to do a third pizza. But that third pizza we see is going to be in fourths. So we're going to put fourths here. That's not a pretty line. All right, so we got three. Wow. Nope. Take that back. So let me draw this out. 2 minus 3/4. So I already have 2, and I have to take away 3/4. So now this 2, I'm going to keep this one here. This is a whole one. And I have to take away 3/4. I'm not adding anything. So this one here, I'm going to break into fourths. And normally it was all shaded in. I'm going to get a different color to show that shading. So normally it was all 4 squares shaded in. 2, 3, 4. But what happened? We had to take away 3/4. Maybe we ate it or we had to share it. I don't know. But when we had to take away 3/4, we had to take 1 of those fourths away, 2 of those fourths away, and 3 of those fourths away. So that leaves me a remaining of what? One whole pizza plus a fourth. Look, there's even little crumbs left over. Look at that. Unbelievable. So 1 1/4 pizza left. So that's what it looks like as a model, what's going on. So you have two whole ones, and then you're taking away 3/4. That means you're going to break one of these into fourths and take away 3 of those fourths like we did, leaving us with 1 1/4. All right, let's try it again. What if you didn't have two whole ones but 1 1/4? How would we work that one? So let's say we have a whole pizza again, and we got a fourth of a pizza. So let's say this is one whole pizza, and we got a 1/4 of a pizza. Before I shade all that in. So this is 1 1/4. Bam. But we have to take away 3/4. So we got 1 1/4, and we're taking away 3/4. So now what are we going to do with this one? Well, visually we can see that we only have 1/4 here, but we need to take away 3/4. So now we're going to have to pull into this piece of here and take away some more. So we're going to take 1/4 away from this first one. Goodbye. So now there's no pizza here anymore at all. Goodbye, pizza. I'll make this a little bit bigger so I can get rid of that pizza. That whole thing's gone. All right, now we got to get rid of these 2 more fourths. That was 1/4 we just got rid of. So let's get rid of 2/4 and 3/4. So that's a total of 3/4 we just got rid of, because we got rid of this 1/4 and that was a whole piece of that was left. And we got rid of another 2/4 for a total of 3/4 gone. Now that leaves us with what? So that leaves us with only 2/4 of a pizza remaining. Or reduce that to 1/2, as you can see, 1/2 of a pizza. So visually, that's what's happening with these fractions. So I don't want you to just see a fraction and think, oh, look at these numbers, I gotta do some kind of operations. But visually, if you get down to it and get stuck, you can always just draw some models and kind of think through it and say, oh, I'm just taking away 3 of those fourths. So especially if they have the same denominator, it works out pretty simply. So what's the rule? So what did we do? We write the problem in vertical form, compare the 2 fractions. If the top fraction is larger than the bottom, we're going to go to step 3, which is just subtract the fractions, subtract the whole numbers. But what we'll notice, this is where it gets different. If the top fraction is smaller than the bottom fraction, the numerator, we have to borrow a whole from the one before it. Now, it's kind of tough to read all that, so I'm just going to pull up one and work it out. So let's look at this one, for instance. So let's set this up vertically like we were doing in our addition. So this is 3/5 minus 2 4/5. 4/5. All right, so we normally want to compare the 2 fractions. If the top fraction is larger, we're actually going to look at the fraction portion first before we do these whole numbers. And I notice I can't do 3 minus 4 because 3 minus 4 is going to give me a negative number. So I need to do something that's going to change this so that I can have an operation. And what I'm going to do is I'm going to borrow one of the ones here in this 5. So what do you mean by borrow? So 5, of course we have 5, but we can write 5 as 4 plus 1. So I'm going to take away one of the numbers from 5 and make it a 4. So I'm going to make this a 4. But what I'm going to do with that 1? Well, for that 1, I'm going to add 5 over 5. Because 5 over 5 is equal to 1. So by adding this 5 over 5, this makes this now 8 over 5. Because 5 plus 3 is 8. So now my fraction is 4 8/5. I feel like I should do that again. So let me back up. So just in case you missed it. So right now we have, let me go back to making this original of 5. So right now we have 5 and 3, but we can't do 3 minus 4 because it's going to give us a negative. It's going to kind of mess things up. So what we can do is rewrite this fraction 5 3/5. We can rewrite it so that it's equal to 4 8/5. Why? Because all we did was take out a whole number, which is 5 over 5, and add it to 3 over 5, which gave us 8 over 5. So this is still the same thing, but now it's going to allow us to do the appropriate operation. So let's do that. So now we're going to do, let me go ahead and make the problem new. So now we got 4 8 over 5. So now I can subtract. I can say 8 minus 4 is 4, and 5 is going to stay just 5. And I can say 4 minus 2 is 2. So that's a lot simpler. Once I deal with that initial problem, I can see that I'm going to have 2 4/5. All right, let's work another and drive this point home a little bit. Another way, if you didn't like that way, pay attention to this one. So another way we could have done it is just simply change them to improper fractions. Now, I'll be honest with you. This is the way I prefer, and that's why it was important that you learn how to change a mixed number to an improper fraction. Why? Because it just makes this process simpler. So now I have a mixed number. To change a mixed number to an improper fraction, I remember I need to do 9 times the denominator plus the numerator. So 9 times 11 is 99, plus 6 more is 105. So now this becomes 105 over 11. So simple, right? So now, and I'm going to ignore that negative. I'm just going to do 7 times 11 is 77, plus 10 more is 87. So when I was doing my improper fraction, you ignore it, but we're going to still keep it there. But we don't want to say negative 7 times 11. We just want to say 7 times 11. So 7 times 11 is 77, plus 10 is 87, still have the 11. Now this is so much easier, right? Because all I have to do, because I know the bottom is going to be 11, 105 minus 87. This is just a math question. A pretty straightforward math. 105, 87 is going to be, what, 13 plus 5, which is 18. Because I'm adding up to 100, 87, and 13 more to get to 100, plus 5 more is 18. So 18 over 11. I could leave it that way as an improper fraction. They may want the answer this way sometimes. But I'm going to go ahead and change it to a mixed number just to make sure you see it as a mixed number as well. So 18 divided by 11 goes in there one time. 7. So now I can say this is 1 and 7 over 11. So both of these are right. It just depends on how they want you to answer it. So those are two different ways you could have answered that. We just showed one way where you can borrow a number or convert one whole number into a fraction, or you can just change it to an improper fraction, which honestly I think is a better way to go. I think the other way can tend to be a little bit complicated. So did we answer our question? Absolutely. How can we model subtraction? We showed how we can model subtraction by assuming someone's eating a pizza that we have. We had a whole pizza and someone ate a third, or we had 1 1/4 pizza and someone ate 3/4, and we just started crossing those, erasing what was missing. So what are two ways we can subtract mixed numbers? So we showed that. Let's just kind of real quickly model that again. Let's say we had, let's make this 11, so that's a bigger number. And let's make this 1/3. So we showed that you could, if you needed to, change this to a mixed number. 11 times 3 plus 2, 2 times 3 plus 1, and then subtract it straight across. Or you could put it vertically to 1/3. And if this number is bigger, then we could just go ahead and subtract. 2 minus 1 is 1, and that's going to be a 3, and 11 minus 2 is 9. So the only problem that happens is if this number is lower, then we have to do something different. So I do want to show that one more time just to make sure there is no confusion. So let's say we got 10 and 3/5. I'm just making this up. 6 and, make sure that's lower. Let's say 6 and 8/5. So you see how this is lower? So 3 minus 8 is not going to give us a positive number. So we need to take away a number from 10 and make it 9. So instead of 10, we're going to make this 9. So what did we get? What are we going to do with that whole number we just took away? Well, it's going to be 5 over 5. So 5 over 5 added to this 3 over 5 is 8 over 5. So instead of using 10 and 3/5, we're going to use 9 and 8 over 5. So now I got 8 minus 8 is 0. So this thing actually just goes away, and I have 9 minus 3, that would be 3. So that's, I wanted you to be able to see it both ways. So we saw it 3 ways, really. We saw it as a model. We saw it using vertical, and we saw it horizontally where we can change to mixed numbers. Hey guys, thanks for tuning in. I'm the Brandon Clayton, the Algebra Guy, and I will see you next lesson.